Hello.
Or good morning or good evening, depending on your time zone. This is Emre Tokel from the BIS MED IT team. I would like to welcome you all to the Fusion Metadata Registry webinar on validating SDMX data. As you may already know, FMR, the Fusion Metadata Registry, is a free-to-use structural metadata registry for the SDMX standard, which is sponsored by the BIS to support the SDMX community. In addition to metadata management, FMR is offering some powerful data processing functions as well. Validating SDMX data for sure is one of these features, one of these functionalities. Today, our colleague Glenn Tice will present the details about this functionality. Before getting started, I'd like to remind that this session is going to be recorded for potential training purposes in the future. For your questions, you can use the chat functionality as well. And welcome again. Glenn, may I leave the floor to you?
Thank you, Emre. Yes, thank you, everyone. Yeah, so good morning, good afternoon, and good evening to everyone, wherever you are. So as Emre said, my name is Glenn Tice, and I'm going to spend probably about an hour today on a very brief introduction to SDMX data validation using the free-to-use Fusion Metadata Registry tool. So there's quite a lot to do with the data validation, so we're only going to be able to cover some of it, but hopefully we'll be able to give you a reasonably good introduction to the sort of functionality that's available. So let's quickly move to the next slide. So just as a very brief introduction to the topics I'm going to cover today, we're going to start by looking at the key use cases that FMR is designed for with data validation, particularly in the official statistics domain. There'll also be quite a lot of hands-on, so we'll be working with the tool, so you can see it actually in action. So we'll see how we can use the web user interface to validate data interactively, and we'll also see how we can use the same user interface for creating and defining the validation rules. So FMR has a number of built-in validation rules, so we'll have a look at those in detail before we move on to a little bit more an in-depth look at concept representations and how we can use SDMX constraints to help us define the universe of what we believe the universe of valid data for validation purposes. I'm going to conclude with a very brief look at how we can create so-called balance equality validation rules using something called validation schemes, which is a unique feature within Fusion Metadata Registry. So let's launch straight in, and I thought probably the place to start is by defining very briefly what we mean by validation within this context. Well, validation certainly for Fusion Metadata Registry is all in the pursuit of data quality, and we all know how useful data quality is for effective statistics production and effective statistics exchange. Now, we judge data quality using a set of rules that the data must comply with. And FMR actually has two roles in this respect. The first role is to help us define those rules. So we'll see how we can do that a little bit later. And the second is to actually execute those rules. So again, we can use those rules with Fusion Metadata Registry's data validation processing function to actually validate some data, and it will tell us whether the data is valid or not according to those rules, and specifically where the issues, the data quality issues lie. So data quality is really helpful. It provides a couple of sort of key benefits. It's pretty key to data governance. Data quality is absolutely necessary for trust in data, which is the cornerstone of data governance. But perhaps at a more practical level, effective data quality or effective data validation means we can improve the efficiency of data exchange. Exchanging or transmitting invalid data means it needs to be retransmitted or reprocessed, which sort of adds to the cost and adds to the time of the data exchange process. So data validation is all about data quality. In FMR, we create these rules, and in fact, the FMR has about 9 separate rules that we'll have a look at in a minute about precisely what those rules are. So FMR validation function is designed for 3 key use cases. The first, as we explained earlier, was concerning data exchange and data reporting. So as a data reporter or as a data producer, statistics producer, you can use FMR to validate reported data against the collector's rules prior to transmission. So this is really helpful if the data collector can share their data structures, their SDMX data structures, and other things like constraints associated with that. You can load those into FMR, and as a data reporter, you can pre-validate the data and confirm that the data is valid according to the data collector's rules prior to transmission. And as we said, this has the key benefit that it avoids retransmission and avoids surprises that the data you're transmitting is incorrect. For the data collector as well, so the data collector, you will want to know whether the data you're receiving is valid. So again, you can use FMR to validate the data that you're receiving from your data providers, and check that against the rules that you have set up within the FMR. So again, very helpful to make sure that the data you're receiving is valid according to the rules that you've defined. The third sort of key use case is statistics production. So in the statistics production lifecycle, then it's important, obviously, that the data is valid, that the data is known to be of good quality as it moves from one stage into production lifecycle to the next. Perhaps in producing data for the dissemination, then it's really helpful to know whether the data that is being produced conforms to particular data rules, to particular data structures and validation rules. So even in statistics production, then the FMR data validation function sort of serve a purpose to make sure that the data is valid according to the rules that you define throughout the production lifecycle. So data reporting, data collection, really helps. Validation really helps with the efficiency of the data exchange process. Statistics production really helps with making sure that data quality is maintained throughout the statistics production lifecycle. So let's stop there with the slides, and launch straight in and have a look at the tool, how this actually sort of works in practice. So let me just switch to Fusion Metadata Registry. So if you haven't seen Fusion Metadata Registry before, this is the web user interface for it. It's relatively self-explanatory. Fusion Metadata Registry is fundamentally a structural metadata registry, so a repository for SDMX structures. So the catalog of SDMX structures is listed down the side here in this sort of menu bar to the left. So we can see here very briefly structures relating to data, so the data structures, the data flows, and other structures like provision agreements and things we'll look at in a minute for reporting constraints and validation schemes. And then below that, in the item section, we can see some of the structures you'll hopefully be familiar with concerning concepts and code lists, and other slightly more exotic things to do with value lists and hierarchies. So today I'm going to work with a particular data structure, and we can see all the data structures here under the data structure menu. So clicking on the data structure menu gives us a list of all the data structures in the registry in here. I've got quite a few, but the one I'm going to be working with is the BIS macroeconomic series structure, which is relatively simple. So we can see what that data structure looks like by selecting it in the UI, and there's a button down here for viewing the data structure definition. So I'll click on that, then it'll immediately give us a summary of what's in this data structure definition. So this is relatively simple to the extent that it only has about 5 dimensions: frequency, topic, which is effectively a composite indicator. The sort of macroeconomic indicators that you may be familiar with. Reference area, obviously the usual reference area. Concepts, primarily country, something called BIS suffix, and the time period. There's a number of attributes which we're not particularly interested in today. Only a few of those are mandatory. So this is the data structure definition that we're going to be working with. So let's start with a practical example of how we might go about validating a set of data. So for the purposes of today, I've created a sample data set in Excel. Hopefully you can see Excel here. So this could be in CSV, it could be in SDMX XML. It doesn't really matter, but for demonstration purposes today, I'm going to use FMR's Excel data format, and that's helpful because it's fairly easy to see and fairly easy to demonstrate with. So I've created a very simple data set. There are only 5 series or 4 series here. As we can see, the block at the top here are fixed dimensions. So BIS suffix collection time format, etc. are fixed. They're the same for every single series. And then for each series, we can see I've defined a frequency value, a reference area value, and a topic code, which is this composite indicator that we saw earlier as such. And then 4 time periods, 2018 to 2021, and some fictitious observation data. So that's my data set. If I want to validate that, returning to the web user interface in Fusion Metadata Registry, under the data menu, there is an option for convert data. And this allows us to load data for the purposes of validation, for the purposes of conversion to different formats, and for the purposes of mapping as well. So let's go ahead and load some data. So there's quite a neat trick here. You can actually drag and drop your data file. So I have my data file. So the Excel data file we were looking at just now, I can drag and drop onto the data file. And if I press the load data button, it's going to load the data and it's going to validate it. So immediately it's given us a summary of precisely what's happened. And you'll spot down here that there is a list of the various validation rules that Fusion Metadata Registry provides for the purpose. So we'll look at precisely what these mean in a minute, but what it's immediately telling us is that most of this is valid. So there's a lot of green ticks, except for one where it says valid representation. And if you click on the errors, it provides us with a little update as to what the issue is here, and it's reporting that there is an issue with the BIS suffix. The value it reported is 0, but that value does not appear in the code list. So immediately we can get a sense of precisely where the validation errors lie, because it's been the quality of this data has been checked against the validation rules that we have set up. So let's try something else. And so I've got another data set here. I'll just open this up. Here it comes. So this is a slightly more invalid data version of this data set. I'm just going to correct that. And in here it actually contains some errors that are put in. So let's go ahead and validate that, and then we can see what the actual result is. So back to our UI. Again, I can just drag and drop onto the choose file there, and we're going to validate that. And immediately we see there are some more errors reported here. So what do these things mean? Well, there's an error reported for time period format. If I click on the error report, it tells us that the data provided for the observation date does not match the expected frequency. So in this particular case, what this means is that I've said that the frequency of each series is annual, using the A frequency code list. But for this very last time period, I've actually provided a monthly date. So rather than being 2021, I provided 2021-06, so June 2021. So this particular rule tells us that I've said the reporting frequency for that series is supposed to be annual, yet the observation date was monthly. So that's one particular example. So we have some more. We have valid constraint here. So it's told us that I have reported a value for BIS topic, BLUC, and that violates a constraint rule. Now we have a look at constraints a little bit later on, but for now we can say that a constraint which has been set up for this particular reporting workflow has been violated for this particular data set. And lastly, with valid representation. So there's a couple of representation issues here. Now, what this means generally is that the values that we've reported for particular dimensions do not fit with the representation. In other words, the coding for a particular dimension. So again, it's told us that BIS topic is an error, and we've reported a value called UDX, which does not appear in that code list. So returning briefly back to our data, we can see here I've included a topic value, UDX. That's the one that is going to be an error. So I know that I need to go and correct that in the data. So if I correct that and return to the same data validation, we should see here that we saw previously there were some representation errors. Those representation errors have disappeared because I've corrected that problem. Okay. So there we go. So back to the presentation. This is what we've just seen. So validation within Fusion Metadata Registry, the web UI has this sequence of loading the data using the convert data function from the data menu. And the data, as I said, can be in any of the standard SDMX formats: XML, CSV, JSON, EDI. It can also be in the Excel format that is defined by Fusion Metadata Registry, which is very helpful for simple sort of data exchange purposes. Once it's loaded, the data validation process kicks in, and we immediately get a report, obviously explaining precisely where the data validation rules comply, or whether the data validation errors. And then the final step, which we're not going to look at in detail today, is you can then do something useful with the data that you've loaded and validated. And in FMR, that is you can either convert that to an SDMX, another SDMX format. So if we loaded the data as Excel, we could then choose to convert it to perhaps XML, one of the XML formats in SDMX, perhaps, or CSV or JSON, or even EDI. Alternatively, we could actually do some mapping as well, so we can convert it to a different data structure. So let's move on. So we saw in Fusion Metadata Registry, we saw in the actual online demonstration there that there were a number of rules available. In fact, there are 9 separate rules in total. So it's probably worthwhile sort of explaining what these are individually, just so that we have a comprehensive view. So the first one is what FMR calls semantic compliance, and this is relatively straightforward. This just confirms that the file you have submitted is well structured. So the XML, if you're submitting an XML, the XML is properly structured. JSON is properly structured, and the Excel, if you're using that, is properly structured. So not particularly complex. So the second rule concerns observations and uniqueness of observations. So what this checks for is that there is only one observation value reported for each time period. So if I would report the same time period twice with different observation values, then that rule would report an error, because there's obviously an inconsistency in the observation values which are being reported. Interestingly, you can in the data file report the same value for the same time period, but provided it is the same, precisely the same value for each time period, then it won't raise an error. So mandatory attributes, hopefully this is self-explanatory. This checks for whether mandatory attributes are reported. So if the data structure definition defines mandatory attributes, they must be reported. They must be in the data. If they're missing, then this validation rule will tell you which ones are missing. Ops status. The SDMX standard observation status code list defines a number of standard observation statuses, and what this rule does is it checks for consistency with the observation value. So an example here is perhaps if the observation status is reported as M, which is missing. So if the observation status attribute status is M, but a observation value is actually included within the data set, then this rule will report a validation error, because the observation status, the observation value, what's actually being reported, is inconsistent with the actual observation status. So time period format, we've already seen this in action, but just to recap, this checks for consistency between the time period, between the actual frequency, which is defined in the frequency dimension, and the time periods which are being which are actually reported in the data. So if frequency is M for monthly, it means that time period must be in the format YYYMM. Similarly, obviously with the additional 4 formats in terms of annual, weekly, quarterly, and so on and so forth. So consistency between the frequency dimension and the actual reported time periods. So valid calculations refers to these things called balancer qualities. We'll see what those are a little bit later. Fundamentally, this is concerning consistency between or consistency rules between series which are reported in a single data set. So valid constraints, again, we're going to look at this a little bit, but more detail later. Constraints are used for defining the valid universe of data, very helpful for sort of individual data reporting purposes. So we'll see that a little bit later, precisely what these things are and how they're used in FMR. And similarly, we'll have a look in a minute about valid representation. So again, we've already seen this in action. This is the check where the data which is reported is consistent with the representation which is defined for the individual components within the data set. So last but by no means least, valid structure. This is actually relatively straightforward, relatively simple. This just simply checks that the data in the data set is consistent with the structure of the data structure definition. So the data structure definition defines a number of dimensions, a number of attributes. So the data is considered valid, structurally valid, if it has the correct number of dimensions, the correct dimensions, and the correct attributes, which are defined in the data structure definition. So that's a brief run through of the nine sort of separate rules or classes of rules that Fusion Metadata Registry provides for data validation. So what we're going to sort of look at mainly in sort of the rest of the presentation, it's really sort of two key things. The first is about how we can use the SDMX structures and Fusion Metadata Registry to define the so-called valid universe of data, and we've got these two ways to do that. The first is by defining representations, setting the correct representations for the various components within our data structure definitions. And the second way to do that is using these things called constraints or data constraints for actually further refining what we consider to be the universe of valid data for a particular data set. And the final thing we're going to look at is this thing called valid calculations, or which are useful defining balancer qualities, and they use these things called validation schemes. So we'll have a look at that in a little bit of detail, sort of like at the very end of the presentation. So let's move forward and start looking at how we might actually define what we consider to be this sort of so-called valid universe of data. So let's go back to our data structure definition and the one that we saw earlier, which is this BIS macroeconomic series. And here's a very sort of simple summary of it. This is sort of a simplification of what we saw in Fusion Metadata Registry a little earlier on. So we know this has a number of dimensions. It has the frequency dimension. We have this topic dimension, which I've called here a BIS economic phenomenon, reference area and suffix, and some measures and some attributes as well. And we could design the DSD with so-called representations for each of these components, just simply as strings. So this is one way to do that. You can do this in SDMX. There's nothing stopping you doing this. The big problem with designing your data structure definition like this is that the universe of data for this DSD is effectively infinite. Because there's no restrictions on what we can actually, the values that we can actually apply to each one of these dimensions, measures, and attributes, because all we've defined is to define simply a string. So assuming that the string length is infinite, it basically creates no restrictions on our universe of data. So for all intents and purposes, everything is valid. So that's not particularly helpful. So in designing our DSD, we could do something a little bit more specific. So what we can do is we can use various techniques in SDMX, and typically for dimensions that means defining our representation as perhaps a code list for each of our dimensions. So for frequency, we may say we're going to define the representation using the CL-FREC code list, the frequency code list, and similarly for the other dimensions. So for the topic, we have a code list defined, the BIS topic code list, and similarly for reference area, and similarly for suffix. So immediately we're defining a very much more specific representation for each one of our dimensions, which is cutting down or refining the universe of data to something that we know to be valid. So no longer can the data set contain any random string for frequency. The values that are valid for frequency are the ones which are defined within the CL-FREC code list. So we don't have to use code list. We can use so-called described representations. So for observation value, we may want to define this as simply a number. So in this particular case, I've said that valid observation values are real numbers greater than 0. And similarly for perhaps the observation comments, well, we might keep that as a string, but we could set some representation limits on that by saying it must be a string between length 1 and length 1050 characters. So that gives us a very much more defined, very much more specific universe of data. So let's go back to the registry and see how that actually sort of works in practice. So if I turn to the main menu, and I go back to our data menu, and I return to data structures, and as we saw earlier, we've got our macro. BIS macro data structure definition here. So if I log into the registry as an administrator, I now have the option up here to work with and to actually sort of modify the structure. So what I'm going to do is I'm going to edit this structure, because it's very helpful to see how this thing is constructed and how the representations are defined. So if I edit the structure, you'll see that we're given the wizard to help us actually find the data structure definition. So the first step of the wizard is similar for all the structures. It just provides us with a means to set the ID and set the name and the definition for that. So if I move to the next step, this gives us the option to find the concepts within it. So basically the dimensions and the attributes and so on and so forth that make up the data structure definition. So these have obviously already been done because we're working with an existing DSD. But if I move to the next step, then for each of these components, we have the option of setting or changing what in this particular form is defined the data type, which is the representation for each component, each dimension, each attribute. So here we can see, hopefully you can see that on the screen. Here we can see that the frequency dimension is enumerated, but has uses the CLFREC code list for the representation. And I can change that if I want to. So there's a button here for changing it, and that allows me here to go ahead and change the representation, either by choosing another code list, or if I wanted to, I could change it to a described format. In other words, something that doesn't use a code list. So as another demonstration, let's leave that, and we're going to go back to a different version of the DSD. So I've got a DSD version here, which I've called BIS macro test. And if I go and edit that using the menu at the top here and move through the wizard, we can see here this only has string representations for each one of the components. So if I wanted to change that, I could say I could come in here and change it from non-enumerated, so in other words described, so something like string or integer, to an enumerated representation, and it gives us a list of all the code lists which are available. So I can now use the search function down here to filter the list of code lists, and I can choose the code list I want there. So that's going to apply the frequency code list as the representation for that particular dimension. Now you'll spot down the bottom here, there is this section which also defines the data format as string and allows us a max length and min length, and even with an enumerated, in other words, a code list representation, you can actually define further restrictions if you wanted to. So I could put a minimum or a max length on the actual representation there if I wanted to for special purposes. So I can say save that, and we can say see that's now set the representation to CL for frequency, and I can do that for each one of the various dimensions or attributes there. So finally, for non-enumerated, or other words described dimensions and attributes, again I choose the non-enumerated option up here, and then I can choose from the list of various standard data types, data format which the SDMX standard provides: string, even HTML, decimals, double. So I could choose double, and perhaps choose a number of decimal places there. So that's how to define the representations in our data structures. So back to BIS macro there. So in defining our data structure definition, we can set up the DSD and define the representations for each one of the components to actually help find the valid universe of data. So there we go. This is what we've just seen. So doing some practice, using the edit data structure definition, or the creation of the data structure definition function in Fusion Metadata Registry. We can, for each one of the components, define whether it's enumerated. We can choose what the code list we want to use, and we can also define if we want to a further restriction. Perhaps a sort of min length, max length, or even a regex pattern if we want to, and this is supported by the SDMX standard and by Fusion Metadata Registry. So that's really helpful, but In certain circumstances, actually, the universe of data, by setting representations on our DSD, can still be too large, and typically this is where perhaps where we're using sort of generic code lists. So the frequency code list actually contains quite a lot of frequencies, even down to hourly or minutely, and for many use cases, for many data exchange use cases in particular, there some of these values are simply not valid. So you may, in your data exchange, want to restrict the frequencies that you can use, or that can be reported, perhaps to annual and monthly, but you still want to use the standard frequency code list. You don't want to create a custom code list which only has annual and perhaps monthly. So how can we do that? Well, SDMX and FMR provides this option called constraints. It's sometimes called reporting constraints, and in SDMX 3 it defines there are actually sort of two types of constraints. One is called data constraints, which is what we're going to talk about today, and there's another type of constraint concerning reference metadata called a metadata constraint. So today we're going to look at reporting constraints, or in SDMX3 what we call data constraints. So data constraints allow us to further refine this valid universe of data for particular data flows and particular sort of data exchange use cases. So constraints can under SDMX be attached at actually a number of different levels. So you can attach it at the data structure definition level. So a constraint applies to all uses of that data structure definition. Alternatively, you can attach it at the data flow level. So it may just be for a particular data flow, where obviously a data structure definition can be used for a number of different data flows. You might want a constraint to apply to just a particular data provider. Well, you can do that, or even the most specific, you can attach a constraint to a specific provision agreement. So in that particular case, you might define the constraints such that only very particular values, perhaps particular frequencies or particular topics or indicators can be reported, or reference areas can be reported by a particular data provider for a particular data flow, and you do that by attaching it at the provision agreement level. So constraints in SDMX and the Fusion Metadata Registry, there are two types. There's something called a cube region constraint, which we'll see in action in a minute. There's also another type called a series constraint, which we're not going to really touch on today. But it's probably worth just understanding that there are two different types of ways of defining constraints range, which are useful for different use cases. So there are two common use cases for these data constraints. The first, as we sort of pointed out earlier, is perhaps restricting the domain for a specific data flow. So an example perhaps is something like the World Bank's development indicators data structure definition. So this is a data structure definition which is common to a number of different data sets published by the World Bank for health and for education, and for other socio-economic statistics. So if we were to look at this data structure definition, we'll see that the indicator dimension within that contains indicators for a number of different domains, for health and for education. So it would be useful in this particular case to add a constraint for a particular data flow to make it data domain specific. So for the health data flow, we could create a constraint which restricts the indicators just the health indicators for that particular data flow. So useful for sort of define restricting what is valid, where perhaps there's a generic DSD DSD which is suitable for a number of different purposes, or perhaps the DSD uses code lists where the number of values in the code list is sort of wider than we might otherwise want. And the second code list is the data. Sorry, the second use case here is restricting what specific data providers can report. So as we saw earlier, it's really helpful to add a constraint perhaps to a provision agreement. So a particular data provider may be reporting data for one particular region. So we can add a constraint to the provision agreement to restrict the data that they can report just to that particular region. And as we saw earlier, we can do that by adding a constraint to a provision agreement. So let's go and see what that looks like in practice. So back to Fusion Metadata Registry, and we return to the home page here. So under the data menu, there's this option here for defining what FMR calls reporting constraints, but these are the data constraints we're just looking at. And we can see that there are a number already set up in here, all of which are this cube region type. But just by way of example here, I've set up one called BIS macro constraints that we can have a look at for illustration purposes. So if we just want to see what this constraint looks like, we can come down here. We can just view the constraint. And this gives us a summary of what values are valid for this particular constraint. So we can see that there are there's these sections for a so-called included cube and an excluded cube. So in cube region constraints, you can define values to include, so values which are specifically allowed, or alternatively you can define values which are specifically disallowed, so the excluded cube. But in this particular case, just for illustration purposes, we've defined it a so-called included cube for two particular components. So the topic, in other words, the indicator component, and for the reference area component. So here we've defined half a dozen or so individual topics, which are valid to report, and just one reference area. So this would be useful for a particular provision agreement, perhaps, where the provider, we only want the provider to report for a single reference area. In this particular case, it's reference area MD, and we only want them to report for a very defined set of topics within the overall list which is available within this DSD. So that's what it contains, and we can drill into that a little bit deeper using the same method as we use for the data structure definition. So if we're logged in as an administrator, we can use the option up the top here to edit the constraint. So we can edit the selected constraint, and again you'll spot that the very first item in the wizard is just setting up the name and ID for this particular structure. But if we move to the next stage here, we can see it gives us the option of actually defining what structure is constrained. And you remember earlier we said that the option here is to we can attach the constraint to a number of different at a number of different levels, at data structure, data flow, data provider, or in this case I've chosen to choose the most specific, which is the provision agreement. and the constraint structure tells us which provision agreement we're actually attaching it to. So the selected components to include in the constraints. So as we saw when we were looking at the overview, we saw that we were restricting the topic and the reference area. So it's just simply a quick question of ticking those. So those are the constrained values that we're actually going to use here. So moving to the next stage in the wizard, well, this allows us to define the included values. So remember from the overview, we saw that there were a list of included values here. So here we can see what those are. So there's a number of included values for the topic and one included value for reference area. So perhaps we may want to change that. We may want to actually perhaps include another valid value for reference area. Well, there's a button down here which allows us to add a new value. So if I choose that, I can choose in this case, the reference area. And I've got the option of either manually entering a value, or because this is a code list, then I can look up a value. And that will give us a list. So what I might want to do is I might want to choose a second value. I can choose perhaps DE for that, and I can add that in by selecting, and maybe select some more. So adding those to our list of valid value gives us a slightly different list of values which are valid for this particular provision agreement. So the last step of the wizard concerns, which I just exited. We try that again. So there we go, back to included values. So rather than clicking on finish, I should have clicked on next. So the last step of the wizard, we saw we can also find some excluded values. So the alternative is I could have rather than including some specific values, I could have created some specific exclusions. Now it's not allowing me to do that in this particular case because it's unmeaningful. So if I were to remove some of these selected areas. So if I remove my inclusions for reference area, so we've now got no inclusions for reference area, I should now be able to find some exclusions. So the alternative to defining included values for core constraints is I could define simply some exclusions. So I could say that actually I would like for this provision agreement all values to be reported except for these ones. So if I add those as exclusions, I'm now creating what's called an exclusion cube from that. So if I finish that up, we go back and view the constraint. So we can now see we've defined some included or some valid included options for the topic. So the provision agreement, so anyone reporting under that provision agreement can only report for these particular values for the topic. But for reference area, any value is valid except for these ones. So this provides a fairly sort of flexible structure for defining a more specific universe of data, even down to the data provider and provision agreement level. Okay, so there we are. Just back to the slide, Lies. This is what we've just seen. So using the data constraints of the maintenance facility in FMI, we can define the rules for our data constraints, and as we saw, we can select this level, so data flow, DSD, provision agreement, or data provider, depending on our use case and depending on how specific we want to be with the constraint rules. We can choose to apply the constraints to one or more components. So we can choose just to constrain one component or many components. And they don't have to be dimensions. They can be dimensions and attributes. We can also constrain the attributes as well. So for observation status, we may want to constrain perhaps only to normal data and not to the estimated data. So constraints can be applied both to dimensions and attributes as well. And we saw with the cube region, we can define the constraints either by using inclusion rules or by using exclusion rules, which is very helpful for actually in any sort of particular use case that you may have in particularly in the data reporting or the data collection space. So that's really all I wanted to say on data constraints and sort of representation. So that this is the two main tools that we can use to help define and refine our sort of valid universe of data. So really helps us to sort of set what we consider to be valid. So let's move on to the sort of final topic here. So the topic here is about sort of balance equalities. So this is really helpful for data sets where reported values or reported observations must be in some way in balance. And this is often the case with perhaps things like macroeconomic data, where perhaps there's financial values which must be in balance, or the sort of example I've chosen here, which is fairly common, where perhaps the reference area or the regions which are being reported are at different aggregation levels. So in this particular example, we have a reference area dimension, and data can be reported perhaps at both the country level and at both the region level. And so we may want to define, or there may be find a validation rule here that looks at the equality or the consistency between the values reported at the country level and the values reported at the region level. So in this particular case, we find a rule that says that the value reported at the EUR or the Europe level must be the sum of Germany, France, Spain, and Italy. So in sort of the example here, I've got three separate time periods which have been reported, and so we can see for 2019. That rule holds true. So the sum of the values for those individual individual country level series does indeed total the value which has been reported for the aggregate European value, and similarly for 2021. However, 2020, there's a problem. So the sum of the values here is 22, and that does not match the value for which is reported for Europe. So there is a balance in equality there which is helpful to detect in these particular cases where the observation values must in some way be in that balance with the data which is being reported. So let's go and see that in action. So back to the registry. So back to our data menu here, and we said earlier that balance equality is defined using these things called validation schemes, which is available within the registry underneath the data. menu here. So validation schemes is not actually part of the SDMX standard. It's something which is sort of specific to Fusion Metadata Registry, but it follows the same principles for structural metadata as standard SDMX structures. So let's drill in things. So I've defined this validation scheme, and again, like constraints and like all structures, we can select that and we can use the view function to see what that actually is and drill into it. And if I click on that, we'll see that it provides us with some information. It tells us that it's this balance equality concerns the reference area dimension, which is what we saw actually on the slide, and hopefully you can see down the bottom here that defines something called a custom rule expression. It's probably a little bit small, so hopefully you can see that. So again, let's open this up. We can use the edit function to see how this is defined and how this is managed. So again, by now you'll be familiar with the first element of the wizard, which just defines the ID and the name for this particular structure. If we move to the next step within this particular wizard, it's asking us to which data flow this validation scheme is being attached. So which data flow this rule applies to. So in this particular case, I've created a data flow called banking statistics, just for illustration purposes. But you can choose the data flow here for just from the pick list of all the data flows within the registry. So the remainder here allows us to actually define these so-called expressions. So I'm going to skip over CSV import in a minute, which allows us to sort of a simple way to import these expressions and go to the expression builder. So the expression builder allows us to define this balance equality expression. So if I return briefly back to the slide, we remember that we defined our balance equality as EUR equals effectively the sum of the country level series, and we could just describe that directly using an expression in the validation scheme. So the validation rule in this particular case, the balance equality relates to reference area. So if I click on reference area, then we can see in here it defines a so-called custom rule expression, which we can see is pretty much as we sort of laid it out in the slide. So if I go ahead and edit that, we can see how this thing is actually created. So in creating the rule, I need to give it an ID, just like all structures within SDMX and within Fusion Metadata Registry, a way to uniquely identify it. And I've given it a name, and I've said the rule type is a custom expression. And the expression in this case finds that I am equating the codes. So EUR. And the equality we set there is equals, and the expression is the sum of these individual values for the dimension. So I can go and I can extend that. So maybe I want to add that. So I can just type an expression here, and I can either pick from the list. So we can see here we've got a pick list. So I might add another value there, or I can just type in the expression. So that's how we build up the expression syntax. So the expression can also contain sort of arithmetic expressions as well. So I could do something like perhaps put that in parentheses, divided by 10. So maybe the values that are reported for the country level are at a different order of magnitude to the value reported at the aggregate level. And so I can apply some numeric expressions here, or some numeric arithmetic in order to adjust that. So the alternative to choosing a code here, is that I can actually choose a value instead. So rather than saying EUR equals the sum, or this particular arithmetic expression, I could, as an alternative, choose a numeric equality. So a typical result here is maybe say 0 equals, an alternative way of defining the previous expression is do something like EUR minus our expression equals 0. So this will have pretty much the same effect as saying EUR equals the sum of those values. So you can achieve the same thing in a couple of different ways. So if necessary, you can choose different equality functions, greater than equal to, greater than less than equal to, and so on and so forth. And it's useful sometimes to add in sort of like a level of tolerance. So rather than saying EUR minus the some of those values, we might say, when we're going to give it a tolerance, and say it must be perhaps less than an error of 0.01 or something of that order. So this is helpful, particularly where observation values are reported to a number of decimal places. The precise value reported perhaps for the aggregate EUR may not precisely add up to the values for the individual countries. So we can set a tolerance value by using this sort of numerical form of the expression. So that's finding a balance equality using these custom expressions. You'll have spotted here, as we saw earlier, on the rule type, we can define sort of what the rule type is. Well, we're working here with these custom expressions, which is these numerical, arithmetic expressions. There is another option here, which I'm not going to look at today, which is actually a rule using aggregates, which is aggregation using hierarchies. So you can automatically define validation rules using hierarchical code lists. So if you create a hierarchical code list, which defines a hierarchy of aggregates, then the alternative is to use hierarchical code list to perform these balance equalities automatically. So that's beyond the scope of today. So I won't go into that any further. So there we go, just to recap. So defining equalities using the FMR validation schemes, this is fundamentally what we saw. So we can define these numeric equalities either using this form, where it is a code equals an arithmetic expression of a number of different codes, or a numerical option, as is shown down the bottom here, where actually the expression to hold true must equal a numeric value, and typically that's either going to be 0 or perhaps some tolerance value. So in the demonstration, I skipped over this option of a CSV import. We saw in the demonstration that we can use this expression builder to actually help build the expression for us. Well, there's another way to do that, and you can actually define the expressions basically as code, or using this sort of syntax that we can sort of see illustrated here, where you can find the expressions perhaps in the CSV or in Excel, and simply import those into Fusion Fusion Metadata Registry using this CSV import function. So this is helpful if you've got a lot of these expressions, and it's more helpful to perhaps maintain those externally, perhaps as an Excel spreadsheet or perhaps in a CSV file. So that's pretty much what I wanted to cover for today. So just to recap what we've actually looked at. So we've had a look at the data validation use cases, and we've seen that FMR is primarily designed for data validation, for data collection, data reporting, and perhaps also data production. We've seen how we can actually validate data and how we can define those validation rules using the web user interface, and we've seen there's a bunch of these validation rules, nine in total. Some of them are fairly generic, like checking whether the structure of the XML is correct. And some of these are more specific, concerning the representations and the constraints. So we've seen also how we can use the constraints and the representations to help us define and refine the valid universe of data to actually make sure that the data we have on our data sets is within the universe that we're expecting it to. And then finally, we've seen about the balance of qualities as well. So very useful if you have data sets where there must be some sort of consistency between reported values. So I'm going to close there. I've seen there's a number of questions coming in through the chat. So maybe helpful to sort of turn to some of those. Let's start. So I see there's a question here about frequency H time period format must be YYYS1 or both are both correct for the half year. Well, interestingly, I think for half yearly, there is a way to set what the half year behaviour is for validation, because I mean, in some use cases, I think the H frequency is used to define hourly data. In other use cases, H is used to define half yearly. So there is a way to actually define the validation behavior with whether SRH are define either half year or particularly whether H defines hourly data. So question from David Balclough: does FMR fully support series key constraints and data validation with them? So yes, it does support series constraints and supports all the series constraints models for SDMX3. So it allows series constraints with the percent operator, which allows for sort of wildcarding in series constraints. It also supports another operator, which is the plus operator as well, which isn't actually part of the SDMX standard, but is very useful for defining a number of different values. So if you define a series constraint trait for perhaps with reference area, then you could find DE plus FR plus IT. So it helps with defining series constraints in a very much more compact way. But I think to answer the question, yes, FMR does support the full series constraints specification and validation with them. So we haven't looked at series constraints today. But it's that may be a top topic for another session. So Cedric's asked the question: is it possible to find cube constraint with the dependency between several dimensions? The answer, I think to that is no. If I'm correct, I think that's probably a use case for series constraints. So series constraints allows dependencies between several dimensions, or defining sort of individual series. So your example here is indicator is ABC and frequency is MQ. That's probably a use case for series constraints. So you could define a series constraint, perhaps, as I mentioned earlier, perhaps using this plus operator. So you could define a series constraint which is A plus B plus C. So A, B, or C are valid for indicator, and then frequency M or Q. And what that'll create is it'll create a sequence of series constraints, which is the Cartesian product of those values. So a valid report or valid series would maybe A and monthly, and A and quarterly, and then B and monthly, and B and quarterly, and C and monthly, and C and quarterly. Series constraints is the way to do that, I believe. Not using cube constraints. Yes, A being monthly data and C is quarterly data, so C should reject data. So if you want more specific rules, then again I think they could be defined using series constraints, but you may have to go down to the level of defining specific series keys. So in other words, if you want to be very specific with series constraints, you can define specific series keys where it says a valid series is maybe A with with quarterly data, and not C with monthly data. So you can be very specific if you need to with series constraints. David Barraclough, the OECD, asks, would it be possible in a validation scheme? What's possible in a validation scheme expression? Is there a list of operators and functions? Yes, there is. By and large, that's described actually within sort of the help and the information within the expression builder page within the Fusion Metadata Registry. The operators are actually quite simple. The equality operators are the ones that we saw in the demonstration. So it's equals, not equals, greater than or less to, greater than or equal to, and so on and so forth. So for equality operators, it's those sort of half a dozen sort of standard operators. For the arithmetic expressions, it's the basic arithmetic expression. So it is addition, division, addition, subtraction, multiplication, and division, and you can also use parentheses as well. So the operators have been kept sort of relatively simple, so there aren't complex operators like modulus and other things. In theory, those could be added, but they're very simple. And if you want to list, I should recommend going to the expression builder page that we saw in the demonstration within the validation scheme editor in Fusion Metadata Registry, and there is some there is some help there. So a further question on the same topic is it limited to validation within one and the same concept? Yes, it is. So it's you cannot unfortunately say if reference area is a particular value, then the concept another concept should be a different value. So yes, so the validation rule relates to individual concepts. More sophisticated rules, I think need to be left perhaps to other things, to other things like potentially VTL or R or something like that, which unfortunately is not currently supported within the Fusion Metadata Registry. So another question from the OECD is that there'd be a bulk uploading feature for the rules in the validation scheme. The answer is yes. I think we saw that briefly, and that's mainly the CSV upload function. So again, if you have a large number of these rules, and often this is the case, then you can actually define these rules using the comma separated syntax that we saw, and upload them using the CSV functions in the maintenance wizard. You may also be able to do it via Excel. It escapes me for the minute, but for many structures in Fusion Metadata Registry, the structure can be exported or can be defined as an Excel spreadsheet, and can be maintained and uploaded or bulk uploaded as Excel. So one of the final questions is, could you tell me more about the metadata update for FMR? Could it be done automatically? I think if I understand this question correctly, I think can there be some automation to update the metadata? Well, the main function or the main way for automation within Fusion Metadata Registry is using the REST API. So FMR provides the SDMX REST API for both for querying for structure and metadata, so all of the standard structures. But you can also maintain, you can also submit structures. And you can also modify structures automatically or through automation using the REST API. So for instance, virtually everything that we've seen today, whether it be data structures, whether it be validation rules, whether it be constraints, can be created, can be modified offline, using some automated processes, using other tools, and can be submitted and managed to the registry using its REST API. So a question here about VTL. How much of VTL is supported in FMR? The short answer to that is, sadly at the moment, no VTL execution is supported in FMR. That may be an option in the future. In the FMR window, you will see a section for VTL. What that relates to is the storage of VTL programs or VTL structures using the SDMX information model. So FMR currently supports the storage and the exchange of VTL, but it doesn't support the execution of VTL programs for the purposes of validation or transformation. So maybe in the future, but at the moment, only storage of VTL in FMR. So thank you. That I think is all the questions I can see in the chat. Please add any more if you think of them. But before we close, I just wanted to highlight that obviously in the introduction today, we haven't had time to go through absolutely everything to do with validation, and a few other additional topics that are worth sort of understanding that are also available for validation. So series constraints, we spoke about earlier. There's some questions in the chat. Series constraints are another way of defining these data constraints, useful for particular use cases, particularly if you have very specific constraints that that you want to apply. And as I think I mentioned in responding to some of those questions, it supports these plus and percent operators, which are helpful, really helpful for defining series constraints. There's also this thing called code validity periods. So this defines the time, a time element within constraints. So codes may be valid only for particular periods of time. So you can further refine constraints and representations by defining validity periods for codes, where you say that the code is only valid for a particular period in time. We touched briefly on when we looked at balance equalities on using hierarchical code lists. So you can use hierarchies for actually defining the automated balance equalities. And also there was a question in the chat about automation. So yes, here we go. Automating data validation, perhaps using the REST API. So you can use the REST API both for managing the structures, but you can also use it for data validation as well. So if you want to incorporate FMR's data validation functions within your data production system, then you can do that using the REST API. And the demonstrations today we saw it being done by the web user interface interactively. You can do it automatically using the REST API. And finally, perhaps in the questions to do with VTL and so sort of more complex validation rules. Well, the FMR validation rules go quite a long way, but they don't necessarily allow for every possible permutation of validation you might want to do. So Fusion Metadata Registry can be used with other tools like R to do perhaps more sophisticated and the bespoke validation. And there are some really nice use cases where you can still use code lists defined in FMR in validation rules that you may define in R. So those are a few additional topics that we didn't have a chance to have a look at today. So very finally, before we close, because we're running out of time, we'll share the slide deck today. There are a few references here that you might find useful. Places to download Fusion Metadata Registry, either as Docker or as an installable application, and some references to some of the documentation and product pages. So that's all. Thank you very much indeed for listening. If there's any further questions, then please send them to me directly, and we'd be very happy to answer them. Thank you very much indeed for your time.
Jürgen, thanks a lot again. Thanks a lot everyone for participating this afternoon. We will be sharing the slide deck, and please get in touch with us for any further questions. We will be happy to help.